Starting. Right, Hangout on Air is live. Hey there, welcome everybody. Welcome again to Astronomy Daily Live. So hope everybody's doing well out there in the universe and the world. I see that Bobby just popped into the panel with a huge echo. Hey there, Bobby.
Hey, what's up? Okay, hang on. I'm about to deviate that echo.
Deviate that echo. So, as Bobby is deviating, let's all gather together, grab our consumables of choice here, and settle in on this virtual porch and get together for, just a little while and talk all things astronomy and science and space and, whatever other tangents we might find ourselves in. The astronomers like to say that the sky is the limit, right? And that's absolutely true. It's absolutely true here. So cheers. I've got the hydrogen hydroxide again. You can see I've already drunk a little bit of it. So, but that's okay. There's more where this came from. It's great.
Yeah, and I got me not too much. I need to refill it though, so faucet water. Cheers.
All right. Well, that is an amazing substance. Totally amazing. And, we humans are sort of hooked on it, right? It's like a serious addiction that if you stop taking it, think about it. If you stop taking this substance, you die. So we are extremely dependent on this thing, which sort of on the one hand is kind of neat, but on the other hand, it's like, man, it's another thing that I have no choice over, right? I have to. I have no choice. I don't like that. I like to have choices. And if I don't want to drink this for months on an end, well, I should be able to do that, but I can't. Anyway, that's one of those things, I guess. So, not that I mind. It's pretty awesome. So, cheers.
And I'd like to welcome Earth Radio in the chat.
Hey, ERRT Radio. Nice to see you there in the chat. So, in the background here, you might hear some choral music. This is last week's Music from the Hearts of Space episode. They actually did a repeat. I think this is episode 1064. So, but it's choral music, beautiful choral music, and I usually can't get enough of this. I'll actually take this and either transcribe it myself or find the sheet music, the actual notes, and then I'll start playing it over here. I'll record all the parts separately, and using a program called Audacity, I can record each part and then mix each part. And chorals are really, really great. They're usually in 4 parts. There's a bass, there's a tenor, there's an alto, and there's a soprano, right? So there's a high and sort of a middle, low middle, and then a bottom. And usually composers like Bach, right? They come up with the most amazing combinations because they're not afraid to use different modalities, right? Different scales, and they actually will mix those scales in one song, and it's absolutely gorgeous. Yeah, definitely encourage you all. If you like space, if you like astronomy, if you'd like to get yourself into sort of a mental state where you're thinking about big things, right? Like the universe, right? Or even the universe inside of atoms, right? Which is a lot of space. Put some space music on, and either sit back, close your eyes, and just sort of meditate and go with the sound. Or what I like to do is this is the kind of stuff that I'll put in the headphones and I'll just work, right? And it's actually what's that, Bobby?
Nothing wrong with that.
Yeah. Oh, yeah, yeah. No, there are a lot of programmers who listen to music. I'm going to look at the chat. Are there shenanigans over in the chat? Good. Haha, yeah. True. Or listen to ERT radio. Yeah, for sure. Bobby, if you have Ron's link, go ahead and post that up. I don't know if anybody else is there.
I posted on the Discord and
okay.
stuff, and that would be better.
Cool.
Okay.
I'm
on the YouTube. YouTube channel on my phone.
Right. There's a lot of programmers who listen to music, but it's usually really heavy, loud, and everything else. And I've never really gotten into that. I like this kind of stuff where it is very sort of ambient, but it is there, and it definitely makes a difference. It definitely allows me, to sort of focus more on the work, not necessarily be more productive. I think we have an obsession with productivity, and I don't think that that's a healthy thing. I don't think that we always have to be productive. I think that we need to just sit back and enjoy ourselves. And ERT radio, I don't know if there are any copyright problems or not. I play this in the background.
It's going to strike for no freaking reason.
It might, and so be it.
There's a lot, especially people that uploads radio stuff are getting hit with copyright.
Yeah, and we
discussed that one about a few days ago, right?
Yeah. You had pointed out an article, and yeah, I think sort of what my own conclusion about what YouTube is doing is that YouTube shouldn't be the copyright police.
Even with your own music, you can still get hit.
Yeah, you still can. Yeah. Yep, it happens. So yeah, if it does here, it does, and I'll take the necessary steps. But I've been actually playing this kind of stuff in the background for a little while now, and absolutely nothing at all. So is it either it's not being recognized, it's not being heard by the algorithms, or it's just not a big deal. I should actually be playing a little bit of my own. I could do that. So, but all right. Well, cool. Well, I'm glad everybody's here. Cheers.
Yeah, that's true. It's bad that YouTube is supposed to be a sharing platform.
Yeah, I really don't think that YouTube should be the copyright policeman. I think that they should just be a platform, you know, put things out there. If if somebody like myself, right, is a creator, and I want to ensure that, you know, my music is only paid for, and not played, you know, for free anywhere, then that's on me, right? That's not on anybody else. That's sort of how I see it, at least. So yeah, you know, YouTube, I think, is sort of trying. They're probably being pressured into this, you know, from the advertise. I'm not exactly sure.
And what's
You
also
know,
sad is they know about this abuse for quite some time and they never did crap about it yet.
well, it's a tough nut. I actually think that they're probably working on this really, really hard. It's just really, really hard to, you know, do that.
It's either they're hard, it's hard, or they just don't want to do it.
Yeah, I think it's the former. I really, really do. It's that's a tough nut, and like I said, I don't think that it's YouTube's job to be policing that. Um, so
And Earth Radio, he had a copyright strike after he got the permission from the creator of the song.
yeah, yeah. So you know, we're sort of. I mean, you know, we are in the in the pre-infancy of all this network stuff, right? I mean, uh, um,
Welcome, Uncle Bill. Productive depends on what you count as a product. In my opinion, I'm more about passion, pursuit, and self awareness.
yeah, 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 exactly, exactly. So you know, my bottom line is, you know, am I having fun? Am I doing things that you know, are pleasing to myself? Because usually, you know, what I've observed is that, you know, this universe is fractal, right? So you know, the things that I do at my scale are probably also working well at larger scales and smaller scales. So you know, um, I think, you know, the kinds of
Jules
things.
is under the weather as well. He didn't do his BHF UHF show.
Oh yeah, yeah. He mentioned on yesterday, I guess, that he wasn't feeling too well. So yeah, you know, knock on wood. I don't think I've been sick in, wow. It's been a pretty long time. Luckily, I'm a pretty healthy dude, and when I do get a cold or anything, it usually lasts a day or two, and then it's gone. Um, and they've been really, really, really mild. Even the flu things have only lasted a couple of days, and then it's gone. So I think that's a lot of luck, and you know, maybe a little bit of lifestyle too. You know,
And I'm out
I
of curiosity, you ever want to be a ham review operator?
probably someday. You know, in fact, I was going through some of my books, and here I'll pull this one off the shelf, which you'll probably recognize. This thing I got. I don't even know when I got it. It was so long ago. Oh, okay. so so there it is. But look at the date. Come on, you can focus. There we go. So it's a little outdated.
Yeah,
it's only
true.
it's only 20 years out of date. But so yeah, you know, even back then I was like, yeah, you know, I should do that. And I just found a piece of paper in it, so I like to look at these old things. Okay, it's just a I used to use this kind of paper, you know, this grid stuff, and it's just a shopping list. It's just a shopping list here. soy sauce, olive oil, pistachios, fruit, garlic, just the usual boring stuff. All right, well, I'm going to put it back in the book. I don't remember where it was, but it's going to go back in there. So, yeah, at some point, yes.
It's gotta be crazy. You got a shopping list. You remember everything.
What's that?
It's kind of been funny. You had a shopping list in that book, and you still remembered it.
Oh, well, I mean, I'm just reading the list. So here's some looks like some kind of IP addresses too. So who knows what I was doing? I don't know. But yes, ERRT. I do try to drink quite a bit of this hydrogen hydroxide. Sometimes though, I'll go a little crazy, and I'll get a big mug of dihydrogen monoxide, H2O, and phew, that's pretty amazing stuff too. So, to answer your question, Bobby, yes, at some point I definitely do want to be a ham, but when and if that will actually occur, I don't know. Maybe someday. Who knows? So one of the things that I've been sort of well, what I should do first, let me give you a quick update as to what happened last night here. So it looked like it was going to be clear. So it's like, okay, it's going to be clear. It's not going to be any moon. So I'm going to go out and actually do some photometry. Pull out the telescope here, put the camera on it, and go out and start doing some photometry on my list of target stars that I'm going after. And so I set that all up. What's that, Bobby?
Oh, nothing. I was just talking to myself.
Oh, all right. I do that too. So went out at sunset, took my flats, I took my darks, that go with the flats, and I explained what happened last night, trying to focus. That that was just stupid. Anyway, after the live stream, I went back out, and it was beautifully clear, beautifully clear, right? Did the star alignment, so the telescopes could actually track things. Went to my first target, and literally, as soon as I found my first target, I was watching it. Right, it was right in the center of the field of view. I was all set to go. Right, I mean, I was going to push the go button. Right, grab 100 images, and all of a sudden it just disappeared. It just vanished. And so I'm like, what happened, right? And so I turn around and I look up, right, to where I'm pointing in the sky, and it's just black. It's just completely black. There's no stars. You got to remember where I live, right, is very, very, very dark. So clouds don't look lit up, right, because there's nothing to light them up. Usually when you live in a city and you've got clouds overhead, they're actually lit up, because of the city lights. So there aren't any city lights here, so they're just when I look up in the sky, there's just areas of darkness where they're where there should be stars and there aren't. And I looked in the vicinity of where I was pointed, and there's no stars there at all. And it's like, oh, really? Really? So I ran into the house here, got on the computer, looked at the satellite loop, and looked at the picture actually that I posted over on the Discord server. If you look in the extreme southeastern corner of the state of Arizona, you will see that there was this cloud, right over there, and that cloud wasn't moving, but it was expanding, right? It was expanding. So I'm like, oh, really? Really? So I also noticed when I went back out that everything, including the telescope, the computer, everything had this nice thin layer of frost on it. So, okay, clouds, that's, sort of a showstopper, but clouds can go away, right? Clouds, can come and go. When I saw that frost on everything, I'm like, okay, it's done, right? So, man, I got to the first target. I was all ready, to push the button, and I had to stop. It's like, but that is the life of the astronomer, especially the research astronomer, the observational astronomer, where I've got a desk job, but I'm also out collecting data. So that was a bummer. The one thing that I can say is that how I was dressed worked really, really well. I was actually very comfortable, and it was probably below, well, really, really close to 0 Celsius. Really, really close. It was probably around like -1 or so when I stopped. So it was cold. It was cold, but the layering and everything that I had on worked really, really, really well. So I'm glad about that. I actually today I've had this thing for quite a while. It's a little weather station thing, and it has a remote, right? So I've put this remote outside in sort of a protected area. I've got a porch, and I put it up, and so I can actually look now and see what the current temperature is, Fahrenheit, and the current relative humidity, and so it looks like right now I'm at 33.6 and 53%. So that's getting a little bit cold. I should actually switch that to Celsius. I can do that. There we go. So I'm at 0.9. It's kind of hard to see there. 0.9 Celsius right now. So I think this is kind of a nice thing to have, because I really want to keep track of the humidity, especially. Usually here, in the desert, we're really, really dry, but can get wet, and things can frost up or dew up here. And when that happens, I definitely, there's no way that I can do any kind of observing. And that's an interesting thing. I'm going to do a my weather too and just see how close it is to what I'm seeing. So over on the chat, I just did a my weather with my zip code, and Nightbot should come back. And okay, so it says it's 30. So I'm not exactly sure, where it's getting that kind of info or not. Hey there, Andy. Nice to see you in the chat. It's a -4 there. So yeah, in the north here, it is winter time, and the solar angle is such that we just don't get a lot of that direct heat, direct light, and so it's colder. That's all. That's pretty normal. So although today here was sort of the coldest day that it's been in quite a while, I don't think it got much above like 4 or 5 C or so, which is kind of unusual for here. But we had clouds all day. Just to the south of me, it snowed almost all day. I guess some places to the south of me had several inches of snow. I got none. So see, the snow people up there, they listen to me. And they know that I don't like it all that much. So they put it somewhere else, where people like it. So all right. Well, anyways, so that's an update with the observing stuff. The kinds of measurements that I am trying to make right now sort of require the moon to be out of the way. So now is a good time, right? Because it's I think it's third quarter. We could actually look that up and find out exactly when, but it's really close to third quarter, which means it is rising. It's rising at about 6 a.m. local time. Is that right? No. I'm gonna have to think about that. But yeah, I mean, at least in the early evening, right? It's not up. So I've got a nice dark sky. Don't have to worry about any of that. I can handle a little bit of moon, but I just don't want it blasting in. I should probably do a little bit of experimenting with that, to see how bright my sky actually gets. But it does get bright when the moon's out, and because the Earth is turning and actually the moon is moving, the brightness of the sky changes over the course of a night when the moon is out. And yeah, I could probably handle that. I should probably maybe loosen that constraint a little bit, and actually do some observing, do some data collection with the moon around, just sort of see, if there's any kind of difference. That would probably be a nice experiment. Anyway, so that's how that's going. I've been playing once again with my stereoscopic pictures. These are the kinds of pictures where you have a left image and a right image, and you cross your eyes, and you can actually see things in 3 dimensions. And so the last time I did this, a few days ago, I was working on this, and for the rest of the day, I was just dizzy, right? I was just like, I mean, the whole world was just spinning, right? Well, tonight, actually, a couple hours ago, this afternoon. It's like, well, I'm gonna let's see what happens if I just do it for a few minutes, right? Because I want to work on this. So I worked on that for maybe 5 minutes or so, right? I think I crossed my eyes. I think I looked at some new pictures that I'm making a few times, right? And I gotta say that I don't know if it's me. I don't know if I don't know if it's the pictures I'm looking at, but for some reason, doing this work is making me dizzy, right? Almost a nauseous dizzy. And I mean, it's been a couple hours, and I'm not extremely dizzy, but I'm like, whoa. So don't know what's going on there. If anybody has any suggestions, uh, I don't know if I don't know if it's me, that I'm just, not able to handle that kind of thing, or if it's the actual pictures themselves that is sort of doing it to me. Probably what I should do is, wait until this dizziness is gone, and then I'll go and look at some actual ones, that somebody else made, that's sort of, tested and true and everything else. Um, um, uh, and see if it does exactly the same thing. Because the interesting thing is that when I first started working on this a couple of weeks ago,
it's a common problem with a lot of people in VR headsets.
I guess, yeah. But I mean, a couple of weeks ago, when I started this, right, I did it for hours and hours and hours, right? No problem at all. And then this last time, a few days ago, I decided to work on it in the morning, and all day long I was just in just this spinning fog.
Some of us are very sensitive to the lack of focus distance with the parallax.
Okay, yeah. See, that's why I'm thinking, Uncle Bill, that it's probably how I'm producing the pictures. I did post one to the Discord. It was a star field. I took the Gaia data and made a stereoscopic picture there. But I've sort of moved on to some other stuff. I've actually been taking these kinds of images. These images are actually three-dimensional that I've just projected to a two-dimensional shot. But these things actually come out of the wall, right? And so I've been looking at these in sort of the stereoscopic way. And these are the things that are making me spin. So, maybe it's just how I'm producing them, right? Oh, there goes the doggy alarm. So yeah, I just have to continue to work on this and sort of be a guinea pig. I've got the doggy alarms in the background. All right, well, cool. Speaking of these, you might be interested in how I produce these. So we can actually sort of go through that today. Could be how I'm displaying the picture. Yeah, I can. So I can change the size of the picture on my screen. So I can make them really, really small, so I don't have to cross my eyes as much. And it doesn't seem to matter. You know, after a few minutes, I was just spinning. So yeah, don't know exactly. But these images are actually created using um, um, astronomical data. It's actually orbital data of the 4 Galilean moons of Jupiter. You can sort of see this this pink part here. This is Io. The bluish part here is Europa. The greenish part here is Ganymede, and then this larger one back here is Callisto. Now it's a little bit more complicated than that, but you can sort of see the orbits in there. I'm showing here sort of the relationships between those 4 moons. I'm colorizing them and all that. But I'll show you the source of this data. It's a publicly available site that's actually very, very cool. And I've shown it here before, but it's been a little while, so I thought I would bring it back up. It's called the JPL Horizons website, and I think I've got it already set up here. Let me make sure. Yeah, I do. So let me share my screen, and we'll just have a little bit of fun here, making some plots. So I'm going to share my screen. So here is the JPL Horizons website, and I will I'll actually copy and paste this link into the chat so you all can see it there and grab it. And I'm going to zoom in a little bit. Now, this site does take a little bit of just a little bit of a learning curve. You know, you have to set various parameters and all of that, and there's actually a number of directions that we could possibly go at this point. I'm trying to think of the best way. Let's do a couple of things. One of the things that this site can do is it can actually give you the ephemeris, or a list of positions versus time of any object out there. And it can display it in a number of ways. One of the ways that it can is actually show you the right ascension and declination as if you're standing on either the Earth or some other body, right? I mean, if you want to be standing on the sun and get the right ascension and declination of Jupiter, you can. If you want to be standing on the Earth and get the right ascension and declination of Jupiter, you can. You can be standing on Pluto and get exactly the same thing. All those numbers are going to be slightly different, right? You can also get these things that are called vectors, which are just distances between bodies. But let's do the right ascension and declination first, and we'll sort of choose an interesting target body here too. So I'm going to change the ephemeris type to an observer table, right? So it's just going to show, you know, right ascension, declination. I think it shows a few other things too. We'll go through this. So let's keep the observer location to Earth, right? So geocentric, and in fact, we can specify here a latitude, a longitude. I think we can, at least. Yeah. You know, But let's just choose. Let's choose one of the observatories. Why don't we go for? How about?
Hey, what's up, Tim?
Hey there, Tim. So the closest major observatory to me is the Mount Graham
And there's Tim on the
International
panel.
Observatory. So let's go down there to Mount Graham. Let's see if it's here. Of course,
Hey,
you
what's
can
up,
see
Tim?
Here we go.
Hi everybody, hope you're all okay.
Hey there, Tim. Welcome.
Sorry I'm late, being a bit busy.
Oh, see how you are? Okay, so we've just chosen a geographic location for the observer. Mount Graham is just to my north. I just sort of chose that one. Like I said, you can choose a latitude, a longitude, any other body in the solar system as well. So yeah, it's extremely flexible that way. Let's choose this one. Now for a target body, what do you think? We can do one of the planets. We can do Jupiter's moons. We can do some spacecraft. One of the interesting ones that I like to look for is the Tesla that SpaceX launched, and I don't remember what that's called. Is it the Tesla? No. What? Oh, Starman. Starman. Is it called Starman? No. I'm trying to remember what that was called. Let's see if we can. Let's see if we can. Let's just do Tesla like that and see if it comes up with something. There it is. So the SpaceX Roadster. That's what it's called. Okay. So we're going to look for, or look at the right ascension and declination of the SpaceX Roadster as viewed from Mount Graham. Got a lot of feedback here. What's Oh, okay, I'm just going to turn that down a little tiny bit. All right, cool. So let's choose a time span. Let's see. Right now it's set for the month of December. So let's why don't we change this to January 1st, 2019, and we'll go to January 1st, 2020, like that. We can choose our step size, right? We can look at the coordinates every hour, every minute, every day, whatever we want. Over the course of a year, why don't we go, let's see, 365 times 24. That's not a lot of data points. Let's just do every hour, I think, 365. Yeah, that's only 8,700 data points. Well, let's go every hour on that. That'll give us some nice resolution. All right, okay, so there's our time span. Let's look at the table settings here, see what that's all about. As you can see, there's a whole bunch of options. So we definitely want to look at the right ascension and declination. But let's do the apparent right ascension and declination. Okay. And let's not worry about the atmosphere. All right. Let's go back to the astrometric one. And we could see how fast it's moving in the sky if we want. That could be kind of interesting. Visual magnitude, sure. Let's see how bright it is. I don't know if this particular object, it's probably too small. It's going to be really, really, really faint. Angular diameter, that might be interesting. We know it's a Tesla, so how big is it actually going to look like in the sky? It's going to look really, really, really small. Well, come up here if you want to. I've got a kitty in the lap. Hello, kitty. Oh, she's gone away. All right, let's see what else we got here. So the observer range, so that's how far away it is. So we definitely want that. Do we need this phase angle and stuff? Nah, not really. As you can see, there's sort of a learning curve here. This is not for the faint of heart. You really need to understand all this kind of stuff. But as you can see, right, they have documentation. So they have an explanation for all of this, right? Every single thing. They explain it, as well as they can. Sometimes these explanations require lots of explanation too, but it's all there, right? So like I always say, if you want to get into this, just be patient with yourself. Don't think that you have to know everything. Try some stuff. See what happens. I mean, there's nothing here that you can do wrong. You might not get what you want, but that's not wrong, right? Let's see. So I think that's about it, right? So position, motion in the sky, how bright it is, how big it is, and how far away is it. That's good enough. And I guess there's some presets here, which is kind of nice, I suppose. But yeah, let's do that. Oh yeah, and then there's all the settings, right? So we can choose what format of date and time. I like the Julian day because it's a single number. Time digits, let's do just hours and minutes because I think we're just looking at each hour. Anyway, units in terms of distances and stuff. Kilometers is okay. Range units, let's convert that to kilometers too. Yeah, again, look at the documentation and see if any of this makes sense, right? You're gonna have to mess around a little bit with it. We definitely want a comma-separated list, right? So let's choose that. Object information, sure, yeah. This is actually really, really useful and nice. I'll show you that. I think everything else is pretty much, I think we're good to go here. So use the settings above, and you can see, these things have changed a little bit. The output is just going to be plain old text. I think you can get, yeah, just HTML or just a way just to download it directly. I sort of like the plain text. Has just a preference on my part. Okay, so we are going to look at the position of the SpaceX Roadster as viewed from Mount Graham, the large binocular telescope on Mount Graham, which is right outside my window here, over the course of a year, 2019, with a step size of 1 hour. So we're going to get, 8,700 data points here, which is just fine. You know, that's not really a lot. So let's do it, right? Bam. So this first part is just all the info about, in this case, the Tesla Roadster, right? That they launched on the Falcon Heavy. Let's see. They actually say when it was launched, right? 2018, February 6th at 2045 UTC, right? So, and hopefully people watching this live stream have actually seen that. If you haven't, you need to see that. That was extraordinary. Not only the launch, but the deployment of the Roadster with the Starman in there was jaw-dropping. That was awesome. Anyway, lots of info here. Lots of info here about the Roadster and you know what happened to it and all that. Right? I think no. I think I'm being summoned to put a kitty outside, so I'll be back in just a couple seconds. Hold on. Come on.
Man's gone to sleep, the lazy git.
All right. Okay. All right, so let's move down here because eventually we're going to be getting some data. They have some predictions here as to when the Roadster is going to be, you know, near various objects, right? Pass by the moon, February 8th. It's going to get really close to Mars on October 7th, 2020. It's going to have its first close pass to Earth, really close, in 2047. So mark your calendars and make your plans now. You know, for what?
If we're still living.
Yeah, well, you know, it's only 28 years away, so you know, no problem.
I love the footage on that before the onboard camera battery ran out.
Oh man,
super cool.
That was epic. That was probably one of the most extraordinary things I've ever seen. Yeah, absolutely fantastic. Orbital elements of the Roadster right here. You know, 2-line elements. And so here's our data, right? This is where it sort of starts. And we're going to come down here. And so let me, I might have to make this a little bit smaller so it fits a little bit better. I'd like to make that all one there. Okay. Whoop, that's a little bit too much. A little bit more. There we go. Okay. So just as advertised, here is the, you know what? I'm going to go back. I'm going to add, just for now, I'm going to add the, I'm going to do both, just so we can see the actual date here too. Okay, so we're gonna see all this front stuff again, but here's the beginning, and I'm gonna have to shrink that again one more time. So a little bit hard to see on the screen. My apologies for that, but I wanted to show you the actual date and time, right? So of course this is January 1st, 2019 at 0 hours UTC, and then 1 hour, 2, 3, 4, 5, and it goes through all of January, and then all February, March, April. It goes all the way, right? All the way to the end of the year.
I think you got like all the way up to 2090, huh? Or you fixed that?
No, I went up to 2020. Yeah, January
Okay.
1st. Yeah, 2020. So just 1 year. Just 1 year. So, all right, I'm going to go back up to the top, and we can sort of look at this a little bit. So here is the right ascension, right? 21 hours, 10 minutes, 34 seconds, and a declination of negative 16 degrees, 1 minute, 51.3. And as you can see, over the course of an hour, right, doesn't really change a lot. There's a little bit of change here. And actually, these two numbers, as you recall, are those actual rate of changes. Now, I think that these values are in, I think that's in arc seconds. We can actually go back and find out. In fact, we probably know at the bottom here, they give a little bit of a description of each of the columns. So let's sort of see here's RA and DEC, here's the rate of change, and that is in arc seconds per hour, right? So arc seconds per hour in both right ascension and declination, right? So at least according to this, right, it's moving eastward, right? Larger right ascension and a larger declination, so it's moving north. So it's sort of moving very east and a little bit north, like that. And the apparent magnitude, right, is 29.19. So that's extremely, extremely, extremely faint. Extremely faint. Very, very faint. In fact, they don't even give a size, right? Not applicable. But they are giving a distance, right? And this is in kilometers. So as of January 1st, at 0 hours UTC, the Roadster is almost, what is that, 350 million kilometers away? Is that right? 350? 3.48 times 10 to the 8th. That's what this E plus 8 means, 10 to the 8th. So 348, yeah, I think that's right. It's 348 million kilometers away. So that's pretty far. I think that's right. Yeah. Because if that was a 9, it'd be a billion. So, yeah, I think that's right. And then I think that this last column, delta dot, I think that's the, let's go down and find out. The delta dot is a projection of the velocity vector along this ray. Yeah, so that's just how much the distance is changing, right? So this is like a velocity, and it looks like it's sort of moving away from us, but slowing down and then speeding up and slowing down. I'm not quite sure. Oh, I know why it's doing that. I think I know why it's doing that. This, do you see how it goes from, 8.25 down to what, like 6.56, and then it starts to speed up again, and then it slows down and speeds up, slows down. That's caused by the rotation of the Earth, right? Mount Graham is located you know, on a particular place on the Earth, and the Earth is spinning, right? Like I always say, we're spinning.
And we're
And
at the
so,
welcome Deep Sky Dew.
hey there, Deep Sky Dude. We're looking at the right ascension
Sky.
and declination of the Tesla Roadster over the course of the next year. It's just a fun thing to do. Not serious about this at all, but you know, those kinds of things can be calculated. So let's take advantage of it, right? We're over at the JPL Horizons website, just grabbing some data and taking a look at it. So let's do exactly the same thing, but instead of right ascension and declination, let's change that to a vector table so we can look at the distances and make some plots. I mean, that's what I really want to do, is make some plots. I like plots. Okay, so we've changed that to vectors. Let me zoom in a little bit here so you can see. I think I have to go back in here and maybe change a little bit of this. Oh, maybe not. No, I guess not. So we're just going to get XYZ, which in this case is just going to be distances from the origin, right, which is the center of the Earth, to our target body. So in X, Y, and Z, the reference plane there, of course, is the sun, right? So yeah, so that's how that's going to be set up. So all right, I think these units are all okay. Kilometers, CSV, yeah, okay. So let's generate another ephemeris.
Hey, what's up, Patrick?
Hey, Patrick. Is Patrick on the panel or is he on the chat? Oh, he must be on the chat, huh?
He's on the chat,
Cool.
yeah.
Cool.
Hey, Patrick.
Yeah, he's on the chat.
Hey,
Happy New Year to you,
Patrick.
buddy.
Hope everything's well with you, Patrick. We're looking at the distance from the Earth to the Tesla Roadster as it is right now. So I'm going to zoom out again here so we can sort of see X, Y, and Z here. So most of the components, of course, are going to be with the X and the Y. Z is going to be smaller because everything is basically orbiting in the same plane, right? So the Z plane is going to be pretty flat. And as you can see, X and Y are about 100 times larger than Z. So, all right, this is cool. Let's, why don't we, I'm going to grab all of this. I'm going to do a copy, maybe. And let's put this into a big, huge table here. I'm going to, let's see, let's go here, let's go here. I'm going to make a directory, 18, 12, 30. And let's put it in there. Let's just call it Tesla.csv. So this is going to take a little bit. Pump all that out. So 8,700 rows here, so we can sort of watch the clock go down as this goes. But this will give us some good resolution, and it's kind of fun, you know, to watch the numbers change. So we'll just let that go for a little while. Maybe I'll pop onto the chat, see how everything's doing here.
Pardon me.
So how are things over there in the UK, Tim?
very, very, very damp air. It actually feels colder outside, much colder than it really is.
Is it cloudy?
At the moment, let's have a look. Yes, high cloud.
High clouds. Yeah, bummer. Yeah, cool. Yeah, I got. I don't know if you heard the first part of the live stream, but I last night went back out after the live stream. Actually, got my first target, and the clouds rolled in. I mean, yeah. I mean, as soon as I hit the first target, I was looking at it there. I was going to hit the go button, and all of a sudden, my target just vanished.
Yeah.
And so I turned around and I looked, and there's no stars.
They were waiting for you.
They were just waiting. They were just.
Did you get any footage of 46p?
Pictures? No, I haven't yet.
It's okay. I was just wondering.
Yeah, I mean, it's still out there, and it's still really, really bright. I think it's like magnitude 5.8. So I mean, it's still, you know, pretty darn bright.
I wouldn't know where to look for it.
Well, the best place to do that is over at CalSky. Have you heard of CalSky?
Yes, I have actually. When it first showed up, wasn't it near the Orion constellation?
Yeah, it sort of moved through there. Yeah, but you know, because it's so close to the Earth, it looks like it's moving really, really fast. So now it's okay. It's taking its time here. But let's see. So right now it's 6 hours 42 minutes and plus 55:49. So it's definitely east of Orion and way north. So yeah, I think it just went by Capella, the star Capella, a little while ago. But yeah, it looks like it's heading north.
Might be visible if the clouds would disappear.
Yeah. Well, it's going to be out there for a little while. And
nice sky at the moment.
Can we still see the comet?
Oh, sure. I mean, it's getting fainter, right? I mean, it's magnitude 5.8, so you know, definitely not as bright as it was, but it's still pretty bright. You know, with get out where it's dark, and with a pair of binoculars, you'll be easy to see that. With the telescope, super easy. Yeah. Naked eye. Yeah, naked eye, you're not going to see it even in a dark sky. Our limit with our eyes is about magnitude 6, right? So that's yeah. So I mean, we're really not going to see much, and that's actually a sort of combined magnitude of the whole thing. This magnitude is actually spread out over larger than the size of the full moon. So yeah, it's, you know, really diffuse. But like I said, you know, with binoculars, yeah, you should be able to see it still. Telescope for sure. Yeah, no problem. All right, let's see if this thing is done. Yep, it is. So all right.
Distraction.
I'm going to, no, I love distractions. So I'm going to get rid of all this stuff that'll just confuse my plotting program. So I use a plotting program called GNU Plot, which is absolutely amazing. I'm going to start it up here. GNU Plot. So the first thing that I have to do is tell it how these columns are separated. And of course, they're separated by commas, right? So this is one column, and then there's a comma. And here's the next column, and then there's a comma. And then there's this column, comma, this column, comma, right? So we're mainly interested in this column, which is the date, right? The Julian date. And then these three, which of course are the XYZ distances between the.
Hey, there's Patrick Beatty joining the panel.
Hey
What's
there,
up,
Patrick. Hey, you're back. Yeah.
Mon amigo.
Cool. Good. How's everything, Patrick?
Lots of lag.
Lots of lag. Lots of lag.
Yeah.
But that's how it goes. You know, we're still in the infancy of this network stuff. So I think it can only get better. Hopefully, you know, for sure, it can only get.
Actually, my Hangouts has got far less lag than the YouTube show.
Oh, okay. Yeah, you know, that is usually the case. It seems to be the case. I've observed that too. Anyway, so this column, of course, is the date, Julian date. So that is a useful column. And then, of course, these three are as well. And of course, these are the distances in X, Y, and Z between the Earth and the Tesla Roadster for this date. So let's just plot a little bit of this here. I'm going to do a 3D plot. So I'm going to do that. So let's look at the X distance. Well, X and Y versus time. Let's look at that first. All right, so let's put the time on the X-axis, and so that's column 1. So that's column 1. Here's column 2. Here's column 3, 4, and 5. I'm getting some echo. I'm wondering if that's from Patrick. Maybe.
I can hear a little myself.
Yeah. It's just a little bit distracting.
Music. I hear music. Oh,
well, that's good.
I can turn my Bluetooth if that's what you want.
Yeah, I'm not quite sure. I'm not quite sure if it's Patrick or Bobby. I'm not quite sure who to blame. So I'm just going to point my finger.
Oh, I bet you did. I know what.
Okay, so let's look at the time and the X and the Y here. And so we'll put time on the X-axis, the X distance on the Y-axis, and the Y distance on the Z-axis. I know that's a little bit confusing, but we'll just plot lines. Line width 1 and line color. Let's just make it black like that. Let's see what this looks like. It should. Well, let's see what it looks like here. I don't know what it's going to look like. Oh.
Looks like a movie screen.
Oh, I know. I have to tell it. Separator is a comma. By default, it'll separate things by white space, and that's why that first plot looks so weird. I think this will hopefully look a little better. There we go. Okay, so let's see this. This axis here is time. Yeah, that's a little confusing. Let's put the time on the z-axis instead. All right, so let's go 3, 4, and 1 like that.
That curling in the path, is that accounting for the spin of the Earth?
Yes.
Right.
Yeah.
Gotcha.
So that's how that's going to go over the course of a year. So if we sort of look down on this like that, and I'll zoom in, or I'll make this a little bit bigger. So of course, this is the distance from the Earth, which is going to be at 0, 0, to the Roadster, right? So as you can see, it's pretty much almost a circular, you know, elliptical, kind of an orbit, right? The Earth is going around the sun, and so is the Roadster, but the distance between those two. Wow, I'm hearing somebody's something. I'm not exactly sure what that is.
You're like hearing the pops and stuff. That's probably people popping fireworks around here.
Yeah, no, I'm hearing like a television or a radio or something.
Oh, okay. I know
No
what it
TV
is.
here.
I know what it is.
Ah, now I know where to point the
You
finger.
sounded low too, Patrick.
No, I turned the what you say volume is low, or what do you say?
I think you're good there. I can turn you up a little bit. In fact, there
Well,
we
I plugged
go.
the headphones in. I had the speakers on, and when I plugged the headphones in, it didn't cut the speakers off, so I turned those off. So.
Gotcha. Technical
I'll get the TV.
difficulties.
Let me get the TV.
Okay. No worries. Anyway, so yeah, this is just showing you the distance in X and Y of the distance between the Tesla Roadster and the Earth, and yeah, I'm not surprised that it's a nice curvy thing like that. We can actually look at a little bit of detail here, and I'll bet you that we will be able to see an actual wiggle caused by the rotation of the Earth itself. Let's just look at a little bit of this. Let's see. I think it's every. Let's go from 0 to. Let's go like 30 days. Not quite sure what that's going to look like.
Wow, you know your stuff.
Okay, yeah, I'm still not seeing a lot of wiggle there. It must be really, really, really subtle. Too subtle to really see here.
Hello.
Hello.
Yeah. Now you can hear me.
Yeah.
Looks like a laser beam.
Nice and quiet in here now. So.
Yeah, good.
By the way,
Yeah.
Patrick, it couldn't have been your TV. I think I stole that yesterday.
Got my TV, yeah.
Oh, and for those of you that still, where's the link to Earth Radio? It's actually on the Discord. Links to awesome.
Cool, thank you. Let's just look at time versus X distance, see if there's anything interesting there. Line width 1, line color 8. There we go. So this is just the X distance, right? Just X. And yeah, as expected, right? It's sort of a sinusoidal kind of a thing, you know, because the Earth is going around the sun and the Tesla is going around the sun in different orbits. So yeah, you know, their distances are going to change
Cool Santa
over
battery.
time. Let's look at time versus Y.
Patrick got
So
a
there's-
nice toy for Christmas.
Haha,
Oh gosh.
that's great. All right, cool. Let's do X, Y, and Z.
Oh,
So
even
let's
Tim's
do-
got a new toy.
Everybody's got toys. Cool. This
Nice.
might be the most interesting one. So yeah, this most definitely is not the most exciting curve I've ever seen, but there it is. There it is. So that is the XYZ distance of the Tesla Roadster to the Earth
My
over the
apologies,
course
Matt.
of a year. I'm not seeing anything that you guys are doing. So you know, if you're causing all kinds of mischief, that is completely up
You were
to
just
you.
showing your toys. Cosmic, you missed it.
Oh, I missed it all. Well, I'm gonna have to look at the rerun, and then I'll have to ban them. Anyway, GNU plot is really, really cool, you know, because you can sort of rotate this around and look at it in sort of a 3D way. So that's kind of neat. But yeah, that's what the Tesla Roadster is doing these days over the course of the next year, right? That's what it's going to be doing relative to Earth. So yeah, you know,
The highest
going
mileage
around-
Tesla without even turning a wheel.
yeah.
I kind of like a bit like it that the Roadster is orbiting around the Earth.
Well, now it isn't, right? It's going around the sun, but the way that we're looking at it here is just looking at the distance between it and the Earth, and that's also going to be, you know, this curve, right? We could actually go back, and I think we're running a little bit long, but let's go back really, really quick, and we can do a quick change here, change of pace, and instead of doing the Earth, let's do the sun, like that. I think we can do that, right? And I'm going to change the step size to every day, just so there's a few less data points, right? There's only going to be 365 of them this way, instead of 8,700. So basically the same info, just now it's based on the sun as opposed to the Earth. So let's take a look and see. It's not going to look a lot different than what we just looked at, because everything's just curvy out there. So let's do Tesla1.csv. And we'll paste all that in. That'll be really, really quick. As you can see, it's already in October, November, December. There it goes. We'll bang that out. Get rid of this stuff at the beginning. The editor that I use here is sort of a programmer's tool. It's called VI, and it's old and it's awesome.
The old ones are
I
the
use
best.
graphical text editors.
Yeah, I've used VI from day one. The other popular one that's used is called Emacs, and people who use
Nano is becoming
Emacs.
more popular now. Have you ever tried Nano?
I haven't. I'm not going to switch.
Stick with what you know.
No, I mean, VI is really really great. So yeah, I mean, I would have to really be convinced to switch. I mean, I would, right? I mean, you know, I got to keep an open mind, right? But I would have to be really blown away. And VI has always delivered really really well. Okay, so let's look at the XYZ coordinates of the Roadster centered on the sun instead of centered on the Earth. I think it's going to look pretty much exactly the same. Yep, pretty much exactly the same kind of curve, right? As you can see, over the course of one Earth year, right, the Tesla doesn't quite make it all the way around, which implies that the Roadster is further away, which I believe is correct.
And
here I'm
a
going
newbie question, if you don't mind.
Please.
Does that actually mean that you're viewing this diagram would be viewing the Tesla as if you were stood on the sun's surface?
Right. So this is showing the distance between the Tesla and the sun. So it's, I mean, sort of yes. It's not showing the position of the Tesla in sort of the sun's sky. It's just showing you the distance between those two bodies.
Right.
Also, notice also that, and I haven't really done this fairly. Let me make this nice and. I'm going to make this nice and square. All right. I'm going to make the square square. About like that, right? So 0, 0 actually marks the position of the sun, right? So as you can see, that is not the center of this curve,
Right?
So it is an ellipse with the sun at one of the foci. So that's pretty cool. But, you know, it's definitely, you know, it has a longer orbit than one Earth year, pretty significantly too, right? I mean, that's another, what, third of an Earth year or so, you know, to fill that up. I think.
Given the sun's position, that looks. I know it looks round there, but would it be fair to say that that's fairly elliptical from the sun's?
You know what? We can actually, if we go back here, we can actually look at the ellipticity of the orbit.
I'm sorry, I do keep distracting you.
No. That's what this number is right here. The eccentricity is 0.25, which is pretty high. If this was 0, it would be a perfect circle, and if it was a 1, it would be hyperbolic. So, you know, 0.25 is pretty, pretty eccentric, not insanely, sort of asteroid-like. Many of the asteroids, you know, have that kind of eccentricity. I think let's just look at the Earth's one really, really quick, and then I'm gonna end this because wow, we're way over. So this is Earth, Sun. I just want to look at the eccentricity of the Earth to compare. Let's see, where is it? Are we gonna get it here? Actually, I'm not seeing the Earth's eccentricity here. Of course not. If I want to see it. It's not there.
Solar day.
Yeah, but as I recall, the eccentricity of the Earth, in fact, you know what? We can do this. Just so we can compare here. Eccentricity. 0.0167, right?
Much
So
smaller.
yeah, it's almost a circle, right? Almost a circle, significantly smaller than the Tesla. So, and that makes sense, right? I mean, it's the closest that the Tesla is going to get to the sun is about as far away as the Earth is. But I think it flings itself out. It flung itself out way into the asteroid belt. So, you know, quite a ways out there. So, yeah, you know, the fact that you know, we're seeing, you know, the sun here, it's pretty eccentric, for sure.
You know something?
For
If
sure.
it does actually hit an asteroid, whose insurance is to blame?
Hey, that's a good question. I think they you know, once they flung it out there, I think they sort of
Abandoned
released.
all rights too.
I
Yeah.
think they abandoned everything. Yeah. So, all right, well, cool. Well, we've run way over, which is pretty normal, but I don't like to run too long if we don't have to. So, I'm going to get out of here for now. Thanks, everybody, for coming in. Have a great evening, a great day. Wow, it's almost the end of 2018. Tomorrow is the last live stream of 2018. So pretty amazing. Time fly. You know, I know that I am having just way too much fun because time is flying by. Like I can't even. You know, I've
You
completely.
think time is flying? I was 18 yesterday.
Yeah, wait till you get 73. Yeah.
I've completely lost track of that at all, you know, to a point where I'm just not even paying any attention anymore. It's like, you know, it's today and that's it. You know, whatever day it is, it's cool. It's just going way too fast. So yeah, you know, that just means I'm having a bunch of fun, which is absolutely true. So, all right, you guys, I'm going to get out of here. Take care. Make sure to subscribe if you haven't. Thumbs up, thumbs down. Make some comments. And most importantly, spread the word about this. You know, this is just a group of friends getting together, sharing a passion, you know, for science and astronomy and space and all things nerd, right? Everything nerd. All right, so have a great time, and yeah, I will see you here again in 22 hours and 27 minutes. All right, take care, everybody. I'll see you later.
Bye.
Bye.